In this tutorial we will discuss about types of cathodic protection method of corrosion. Let's start with impressed current technique. In this method, negative current flow into the conducting substance to be protected from corrosion. The impressed current technique requires a source of DC current and auxiliary anode located some distance away from the substance to be protected cathodically. Principle of the impressed current technique. The DC current source is connected with its positive terminal to auxiliary anode and its negative terminal to the substance to be protected. The current flows from the auxiliary anode to the substance to be protected through soil or water as electrolyte as shown in the figure. The source of current for impressed current technique is usually a rectifier supplying low voltage DC current of several amperes. The motor generators or windmill generators can be used in this method. The buried pipe receives current from an external source of DC current from rectifier via an auxiliary anode to the substance to be protected pipe. The pipe becomes the cathodic and the auxiliary electrode acts as anode. Auxiliary anodes are scarp iron or graphite ground bed and it is consumable, magnetite, carbonaceous materials, silver, lead oxide and its alloys. Auxiliary anode should have the properties of good electric conduction, low rate of corrosion, low cost, good mechanical properties, readily fabricated into variety of shapes, able to withstand high current densities with forming resistive barrier oxide layers. The advantages of impressed current techniques are: single installation can protect a large area of substance to be protected. Uncoated materials can be protected in this method. This method is used to protect the materials more than 20 years. Comparatively few anodes are needed. Voltage may be adjusted to allow for environmental and coating changes. Current output can be easily varied to suit requirements. Current requirements can be readily monitored on the transformer rectifier or other DC source, etc. The disadvantages of impressed current techniques are: sparks hazards problem in petroleum or gas supply pipes. This method requires regular maintenances and monitoring. Relatively large chance of premature failure or breakdown. Power shutdown or failure is also the limitation of this technique, etc. Sacrificial or galvanic anode technique. A more active sacrificial or galvanic anode is connected with the materials to be protected through the electrical connection in this technique. Principle. The sacrificial or galvanic anode is set up with current direction exactly as described in the impressed current technique of the corrosion protection. Current flow from the sacrificial anode to the substance to be protected through soil or water as shown in the figure. Sacrificial anode is used instead of the rectifier in this technique. The sacrificial anode includes magnesium, aluminum, zinc, and their alloys so on for steel protection. The sacrificial anode is the source of current for the sacrificial anode technique. The current receives from the sacrificial anode to the substance to be protected, buried pipes. The buried pipes become the cathode and the sacrificial anode acts as the anode. Zinc, aluminum, magnesium, are used as sacrificial anode for the protection of buried steel or iron, because these are more electronegative than the steel or iron. The advantages of sacrificial anode technique are: this technique is useful particularly when electric power is not readily available. This method is independent of any source of electric power. Ease of installation and relatively low installation costs. And it operates for long time without maintenance, only need regular checking of potential or protection current. Suitable for localized corrosion protection. And low risk of overprotection, etc. The disadvantages of sacrificial anode technique are: the small driving force which restricts its use to conductive environments or well-coated systems. The maximum output capacity for the cathodic protection of the materials from the first installation of the sacrificial anode decreases with time and hence additional current may be required to overcome the corrosion. Sacrificial anode requires replacement at frequent intervals. And restricts its use to poorly conductive environments or well-coated systems, etc. Thanks for watching, bye bye, see you.